Hi, this is Jason Gar. I'm heading over to the lab now. We're going to look at the Barro Bueno mud machine and mud project. So happy to take you guys along with me. Okay, I'm walking the secret back way to our lab. Many of you probably didn't even know that we had a lab at the campus here, but we have a really awesome lab. So this project that we're going to show you, the Barro Bueno project, that's Spanish for good mud. And I'll explain a little bit more once we get in here. But the thing that I really like about this project is that we have the combination of really talented people. We got a lot of those here at XOMO, really talented people, and really good teamwork, and a lot of innovation. And then finally, this digital underlay. The amount of things that we're able to do with data is really fantastic. So that's why I wanted to highlight this project. It's one of the most exciting things from a digital perspective that we got going on. So we're about to get to the lab. Okay, so here's Cliff and I. We're in the lab now, and he's got the full the lab coat and everything.
Yep.
It's pretty cool, and he's got his mask on. I don't have mine on. We're gonna go up and look at the lab. Okay, here's Cliff, and we're walking into the lab. So look at all this equipment in here. It's high security clearance access in here. You got to take a CBT to be able to get in. Look at all that equipment.
I know. It's a great facility and great access to. A lot of great resources we have.
This is awesome. And here we got, we can see it right there. It is at the end. All right, so we're fixing to go in. There's Ro right there. Okay, hold on. Okay, Ro, here we are. We're live. So this is Rosario. Ro, what are you doing here in the lab?
Hi, my name is Rosario, and I'm working on the project Barro Bueno here in the lab.
All right. Well, tell us a little bit about it.
Okay, so this is the drilling fluid that we're currently running through the skid. So just to kind of look at the consistency of it for all of you that are not familiar with drilling fluids, they're non-Newtonian fluids. So these are like the yogurt that you have in your house. You take a spoon to it to lower the viscosity. That's what a drilling fluid is.
All right. And what does it smell like?
Terrible.
What does it smell like? Diesel?
It smells like diesel, like when you pump in your diesel in your truck.
Okay. And now we got Cliff. He's leading this project. Cliff, what? Tell us about it, man.
We'll talk about why we're doing this, right? So one thing I have is, so this is a drilling primer for my grandfather. This is 1952, and one of the things that's in here is this little article that's showing rotary drilling fluids yesterday, today, and tomorrow. So even way back then, 70 years ago-ish, the importance of drilling fluids. And the first comment in there is that every drilling operation depends directly upon the properties of the drilling fluid. So what we're trying to do is, we are in that tomorrow space, right? And we're trying to make sure that we understand our drilling fluid properties in real time with the skid that we're about to show you, which is our Barro Bueno skid.
She's a beauty, look at her.
So exactly what this does is, basically it's a flow loop skid.
Okay.
Where we're gonna pull out active mud that we're drilling with, the fluids that we're drilling with. So we have an intake that comes in through here, and we've got a series of filters. Certainly this fluid that you saw is not always the cleanest fluid, so we want to make sure that we keep some of the debris out. So we go through this filter, and then we come into the input of the pump. So this big blue long thing that you see here is our pump, and it's a progressive cavity pump with a gear reducer. Turns at a low rate, very smooth. It's actually running right now. So you can barely hear it, very little vibration. That's so that, all the sensors that we're using on here give us good quality data. So we pull in the fluid, comes out of the output right here, and the first little stretch that it comes into, and the first sensor that we have, is our Coriolis meter, and this is giving us our density, our flow rate, and our temperature of our fluid. And this is pretty much an off-the-shelf sensor. So this skid is a combination of both, what we can get off the shelf that's fairly inexpensive, that we know we get good data quality, and a few little more special sensors, which we'll talk about here in just a few minutes.
And where does that data go?
So this data is all going through Nextfield. It's going into the cloud, into the modern data platform.
Okay.
And then we're able to view it real time, which we'll show here in just a minute. Perfect. So once we go through the Coriolis meter, we go through this loop, this coil that you see on the end, and we know exactly what the length of this coil is. We know what the ID is, and because we have the Coriolis, we know the flow rate going through it, and we have a DP pressure sensor here, so we can see the pressure going into the coil and the pressure coming out of the coil. And based on that, we can get our rheology properties of the mud. So we know basically what the viscosity is, how thick it is, how difficult for it is to flow, or how easy it is for it to flow. And then once we come through that, what we're going to do is we're going to come through this EIS probe, which stands for Electrical Chemical Impedance Spectroscopy.
Wait, say that again.
Electrical Chemical Impedance Spectroscopy. So try to say that really fast.
Yeah.
And basically this is a sensor we developed in-house, and we actually have one over here that's not in the housing.
Wait, what do you mean we developed it in-house?
So this was through the idea, the machining of this here in the lab, as well as even the test fixture itself was 3D printed here in the lab. And we've been running through some data science and data analytics to understand what the values are and how we can correlate them. And basically what this does is this gives us an idea of the stability of our fluid as well as the oil-water ratio. As Ro mentioned, that fluid smells like diesel. It's a mix of diesel, base oil, as well as water. So it's a combination of the two. And this gives us that data. So we did some bench testing with it. Now we have it implemented into the skid. And all the parts of this are about maybe $300 worth of equipment, whereas something on the market was $20,000, $30,000, $40,000. So
wow,
getting some good value out of that.
So it goes through our EIS probe here.
Goes through an EIS probe, and then the next probe that you see it coming down to before it returns back to the active system is the FBRM probe, which I don't actually know the full acronym for.
What is the row? Focus beam?
Focus beam reflective measurement.
All right, so that's particle size.
Yep, gives us particle size. So all those little particles that make up our mud and give us density and some of the other properties, that's where we're getting that data from. And then all of that will be going through Nextfield as well.
Okay, and then it comes out of this hose here, and it goes back to the drum, and it's just recirculated. So right now we're just testing the machine, and we're collecting data. So Ro, tell us about the data that we're collecting, and how does it get there?
Sure. So I'm sure this is really exciting for you all in the digital field. This is the part you actually probably care about. So this is what's called a Nextfield box that uses cellular. It's a cellular device that we use to transfer data. So that is gathering data directly from our PLC. So that goes into the Nextfield box. I can then access that data via the cloud, via Azure. So as I'm running these tests live, I can see what's happening with my skid on my PC and look at everything live.
Very nice. So we got all the outputs from the mass flow meter. We've got all the outputs from the electrochemical impedance spectroscoper, and then all this stuff is going into the cloud. And then tell us about Dimitri. What's Dimitri doing over in? We got a guy, sure. Dimitri, data scientist over in New Jersey, working with CSR, a really smart guy that we call the Data Beast. What's he doing?
Okay, so what is Data Beast doing? So as you all know, we're going to gather a massive amount of data. What Dimitri is helping us with is he's helping us come up with some predictive tools that we can use in the future. So for example, if your density is not where it needs to be, Dimitri is then developing a tool that would then notify folks of when they need to go and check on their drilling fluid because the density is off by a certain amount. The other thing that Dimitri's working on is he's seeing how all of these values all come together to then give us an overall diagnosis of your drilling fluid, right? So just like you go to the doctor and you need your blood pressure and you need all types of checks, this is similar to what's going on with this skid. So then Dimitri then takes all of that, puts it together, and gives us a full story of the overall mud health.
Yeah, so really this has been an amazing project because we have a lab we can do it in, first of all, and then we have some pretty amazing folks that are able to put all these pieces of kit together, and we've got some mud experts that have helped us with with understanding the properties. We've got people who are making up circuit boards and inventing new sensors and 3D printing, and then we've got really the secret sauce in my mind is that what we're able to do with data now, and we can bring that data in through the Nextfield box and into the cloud, and then design experiments and really do a bunch of correlations that we couldn't have done in the past, and taking seemingly insignificant data, electrical data from a sensor, and then making that into some real information that we can use. So that's been the That's been one of the big breakthroughs here. So, hey, thank y'all for showing us the Barro Bueno mud skid. Pretty awesome. All right, signing off.